So let's just get started right away. So welcome. It's a two-day workshop we have today. It's a Pokemon ggplot all workshop to visualize our data with R. So just let me go through a few introductions first. So some acknowledgements to make before we get started with the content. I want to acknowledge this is hosted by the Department of Psychological Science at TTU. And also for our advisory panel, Dr. Robert Morgan, who's our department chair, and our graduate student advisory councils, Sean and Joshua, who are also co-organizers of this workshop. And also I want to acknowledge the artwork by Dr. Alison Horst, who's a professor at a university, one university. So just introduction. So you can find me at this Twitter handle, GitHub, my website, and my email if you have any questions regarding this workshop or anything if you want to chat more. So I'm a third-year experimental psychology student in cognitive science. And some of our projects include neuromodulation using neurofeedback, brain stimulation, neuroscience of meditation, mental flexibility, neurodegenerative populations, and brain influences, and also cancer caregiving. On the side, I'm also interested in data visualization, UX UI interface, development of softwares for neuroscientists and psychologists. And I'm also part of sustainability group, so I advocate for sustainability and climate change. Also involved in some mentoring program and programming education for undergraduates as well. So today we are going to learn about ggplot, which is a plotting software for R. And it's for those who do not know, this is, R is a programming language that can be used to run analysis, but also plot your data. The workshop aim here is to introduce you to ggplot, which is the package for our data plotting, and to get you to know more about the ggplot2 grammar. So GG stands for grammar of graphics, and today we're going to create different types of plots. And for day two, we're going to customize and learn how to emphasize your data. It is okay if you do not understand R at all. We have line-by-line examples and code for you to follow through. And also we'll go through these exercises at the end of every exercise. And also I'll paste the code for the answer at the end. Also, I'll have resources for you at the end of the workshop as well. So today we are going to explore a little bit more about data plotting. So today is more about data exploration. I'm going to skip this. So in ggplot, there are 7 different layers. So we can think about it as layering of like a cake. So we have the data, which we should map your data onto the plot, and then you map aesthetics, which are the y-axis, x-axis, and also later on we can map and the third layer geometric points, which are the shapes. And then we can do faceting to split the plots, add some statistics like regression lines, error bars, and so on. Also, we can change the coordinate system to change how the plot looks and also modify the theme. So today we'll cover 3 mysterious plots here, 3 different types of Pokemon or plots. Okay, and at the end, you will probably be able to make a plot like this, and we'll go through how we can do it step by step. Some additional notes. These are some points or key points for you to take note of during the entire workshop. I have a best practice in R coding, or at least one I think it is, and also a puzzle, which is an exercise for you to complete. And last of all, a hint for you to use when you do this exercise. So now let's get started. Okay, let me get out of this. So if you have downloaded the main repository, click on rvis workshop.r project. So this is the R project folder that we are going to use. And it should pop up like this. Let me close this. Okay, so you'll see on the bottom left, there are files, plots, packages, help, and viewer. It might be different for your console because I made some customization. So scroll down to handouts. Click on basic ggplot 1.rmd. So it's going to open up on the top right-hand corner. First thing first, click on knit. So we create the HTML document. So it's going to take a while for it to create the document we are going to use today. Okay, I have a question here. So could you show again how to download repository? Yes, so there's a link. I'm going to share it with you. Over here, click on code and click on download zip. It will be saved as a zip file. After that, you can extract it as a folder into any directory you want. So you can extract into any directory and then open it. Click on the R project file. So click on rvisworkshop.r project. Okay, so right now we have the workbook out. So this is the workbook that we're going to use today. So if you have successfully nicked the document, this will pop up. If not, there'll be an error that's shown. So the first thing we want to do is to load our data. We can use it. There are different ways, but one way I like to do is to create a list of directories or folders. And there are standard folders we normally have in any R project or any data project, which are where data is stored, data, and the output probably for plots, probably for statistics. And we have file names. And today we're going to use Pokemon.csv. And we will also filter out different types of Pokemon here. There are 18 types of Pokemon, but we are going to use only 7 for today as an example. So the first thing we want to do is to read or open that data using read_csv. So you can see that I use file path, which is to combine the directories and the files together. So this combines root, the root directory, and where the data is stored, and then the file. So once we do that, we have the data here, and then we can filter the types of Pokemon that we want. So I'm going to use the R document here instead of the output because we are going to go step by step. It's the same. So I'm going to use this as an example instead. So if you're following this and you want to use the RMD file in RStudio, you might want to click on the play button on the right. So to run every line before we start using the packages to run our analysis or to plot. So these are loading the packages that are required for today's workshop. Okay, so like I said, so this is what we are going to do it first. And we're going to run it. Click on the top right, the run chunk, current chunk. And then you can see on the left, my data will appear. So it tells you you have successfully imported your data into R. So notice that I separated comment and comment each part to make sure that the readers or the audience know what my steps are. And also I use file path as I explained earlier. So one thing I want you to note is it is good to always create an R project folder for each project that you're working on. So when you open up the project, you will automatically go into that folder. So you don't have to search for where your files are. It could be in different areas or different directories. So what you want to do first after we've loaded our data is to look at how it looks like, the descriptive. So what kind of data are we looking at? How many values, how many rows, and so on and so forth. So you can see we have 529 different Pokemons and 51 different properties of those Pokemon. And you can see that these are the variables. It's a very good package or a function to use to just quickly look through your data. And you can also look at all these basic descriptives like the mean, standard deviation, and percentiles. And also it gives you the histogram. Okay. So ggplot, why do we want to use ggplot in R instead of basic R plotting? So there is a consistent underlying grammar of graphics, which is by Wilkinson in 2005. He wrote a book on it, and ggplot was developed based on that book. And there is a plot specification at a high level of abstraction. It is very easy to follow, very flexible. You can also modify based on the themes. And also many users use ggplot. There's active mailing list, is open source, which has high users. So you can ask for help, look for example of plots online. So first thing first, we want to plot ggplot, we have to create a canvas. To create a canvas, we can use ggplot parentheses and use this pipe, which stands for putting your data, taking this data, putting into the next function, which is the same as data equals df. So to create this pipe, you can use Ctrl+Shift+M in Windows or Command+Shift+N in Mac. So for example, Ctrl+Shift+M gives you that pipe symbol. So I'm going to run this, and you will see that we have created a canvas for plotting. So I want you to try, take 1 minute or so, and use ggplot, data equals df, and see how the plot looks like. All right. So what we want to do here is copy ggplot data equals df, and then click on the right button and run it. And you can see the results are the same as the first one over here. So we have created a canvas. So once we do that, we don't have to attach the data or map the data back to ggplot again. But right now it's still underwhelming because we just created a canvas. There's nothing there to plot, which comes in to the next point. We can add aesthetics. Aesthetics are something that you can see on a plot. They are the position, the x, y axis, the color, the fill, which stands for different properties of color. For color, it's the border of the graph, the points, or the geometric shape. And fill is for the inner color, so what's inside the border. We can add lines. We can have line types, different sizes. So these are aesthetics. So over here, you see that there are different aesthetics here: line width, line type, size, shape, position, x and y, and the different types of color. These are mapping your data to these different properties. So each geom accepts only a subtype of all the aesthetics. There's a geom help page to see what mappings are. So we can click on F1 or click on help and type AES to look at what aesthetics are. So it is important that every time you're unsure of what the functions are, click on help, type in the function, and read what it means. And the good thing is they provide a lot of examples at the end, and you can follow through to reproduce those examples. So right now we want to create a type 1, type of Pokemon versus weight in our plot. So when we run it, we can see now we have the x-axis and the y-axis. So the x-axis are the 7 types of Pokemon that we filtered that we want. And the y-axis is the weight in kilograms, but we still don't have the data yet. Okay, so we've made some progress here. So right now I want you to try spend one minute to set up the x-axis to type 1 and the y-axis to height m. So what we want to do is to copy what we have over here, copy down, and change the weight to height. And then we can run it. And then you can see we have our type versus height. So right now, we are still missing the points because we are missing points, yes, because these points are geometric objects or geometric shapes. They are called geoms. So there are different types of geoms. We have points, lines, box plots, bars, and histogram. These are just examples, but there are more geoms that are available. You can see over here from geom AB line to geom vertical line, geom violin, geom tau. These are all inside your handout. So if you look at the handouts, there is a there's a file called data visualization -2.1. So you can see all these different types of geometric shapes, geometric objects over here. So this is a cheat sheet for ggplot. So first, we are going to create a histogram to look at the distribution of the different types of Pokemon. Here, we are going to look at the distribution of attack to see where all the attack lies, Pokemon attack lies. What's the average, what's the tails, what are the upper and the lower limits. So we can use this by adding geom_histogram to our geom ggplot and aesthetics. So now we have the attack plot. You can see the highest, the most, and you can see the tails lower and the upper end of the tails. So now we get to see the data points. So let's spend 3 minutes. I want you to set the x-axis to hit points, HP, and add geom histogram. So what we want to do right now is copy the above line. And we want to change the attack to HP, hit points, then run it. So we can see the average, the hit points. You can see there are not many Pokemon that has very high hit points or HP, and many are within the range of 50 to about 80. So congratulations, you have now successfully created your first plot using ggplot. So we have created a histogram. We have discovered a new plot today, histogram. All right, next we want to learn more about how to create a bar chart or bar plot. So I wanted you to try this first. So create a bar plot for x equals type 1, y equals weight_kg. Use geom bar position dodge NA remove id.rm is true. So this is remove NAs or missing data. Stat stands for statistics. We want the identity and add it to ggplot. Let's spend about 3 minutes to do this. So what we want to do is to create a, let's type it out. So we want to create x equals AES, remember AES, x equals height _1, y equals weight kg. There's the aesthetics, and then add geom bar. I'm just going to copy. After that, let's look at, yes. So right now you can see the weight of each type of Pokemon. But if you notice, more carefully, you can see that the weight are pretty strange. You can see psychic Pokemon, they are over 1,000 kg. Flying type Pokemon or grass type Pokemon, they are fairly over 200 or 300 kilograms, which is very odd. It's not, it looks very strange. So there's a reason why this is strange. I'll just let me look at the mean scores first. And we can see that in actual fact, these are the mean weight of the different types of Pokemon. Heaviest is 125 kilograms, not 1,000 over here. So what's causing that difference between what you see in a plot and what you get from creating the summary scores? It is because with bar charts, the plotting type is a little bit different because by default, they're plotting with the sum rather than the mean. So there's a question, did we remove null data and what stats is for? Stats is for statistics. Yes, so we're coming into that. So stats, we want to plot the summary. So there are two ways to plot it. So na.remove is by removing null data or missing data that has missing data in one of these variables. So we can either summarize the data first by using group by and summarize like what I did over here. Or you could change the statistics rather than identity, change it to summary, and then put a function that you want to summarize it by the mean. So right now, I want you to try those two methods to plot type 1 on the x-axis and height m on the y-axis. There I'm provided with two hints, group by to create a summary, and then also the second method to use geombar, stat summary. So let's spend 5 minutes for this. All right. So let's do the first one. So what we want to do is type create a summary score. There's a typo. It's supposed to be height, not weight. And once we summarize, let's pipe it again. We create a summary score and then ggplot aesthetics x equals type 1, y equals height. Let's go in. Then we add geombar position equals, I'm just going to copy. So it'll be faster this way. All right, this is the first method. The second method is similar, just that we change a little bit of the stuff here. So what we change here is we added a summary. We changed from identity to summary. Remove null or missing data, and set the function to summary for me. You can change to, you want to change to sum, you want to change to median. It's possible. So we're going to change to the means. I'm going to plot the mean instead. So once you're done, click on the right play or arrow button, and you can see right now the height it's the same for both. And so this is these are the two ways we can create the bar chart or bar plot. So yes, now we have created a second plot, which is our bar plot. The last plot they're going to go through today is a scatter plot, which is good for describing relationship between two variables. We can use jump point to create scatter plots, so points for creating points on the canvas. It's very intuitive. So bar for bar chart, histogram, line for line, point for points. So let's do an example here. We want to look at attack versus defense. And you can see it's a some sort of linear relationship. You can see the points are plotted over the canvas and the X and Y coordinates. So I want you to try to take 3 minutes to plot attack against HP using geom point. All right, so what we can do here is df ggplot aesthetics x equals attack, y equals HP, and then add geom point. So when we run it, we have our ATTA. So right now we have attack versus HP. So congratulations, we've created our last plot for today, basic plots. So these are the basic plots that we will go through for the entire workshop. But right now, we're going to add more layers to it. So these are just single layered plots. Now we can add different layer of geometric objects to our plot. So we can add a regression line or a line using geom smooth rather than geom line. The geom line, geom line is different because you're looking at lines across the x-axis, but this geom smooth is looking at the line pertaining to a relationship between two variables. So there, so I'll have you try to make the regression line by adding geom smooth to your plot we've just created. Let's spend 3 minutes on this. All right, so let's create the line, the smooth. So we're gonna copy the plot we just did. And then we only need to add geom_smooth. And then remember method equals ln. So what this gives you is a plot or the regression line, which looks at the predicted. So there's a question here. Would you please briefly explain what this line is telling us? So this line, if you look at geom smooth underscore, it adds the presence of overplotting effectively. Essentially, you're looking at predicted values for the y given the x. Essentially, that's what it's doing. But there are methods of smoothing. So if we have GLM, general linear model, or other functions, there are different functions of plotting the smooth line. So this is a regression line. So it's essentially plotting given a y value, given this attack, what would you expect the hit points to be? So for example, given that my hit point, my attack is 150, I would expect the HP to be at about 90 something. So those that are on the point or off the point, they represent something else. So you can see that we also have this thing, the confidence interval or the errors, whatever we want to call it. So these are the 95% confidence intervals here. And please note, the order of aesthetics differ. So whatever you put first, whatever you plot first, becomes the underlying layer. And then whatever you put on top becomes the overlaying layer. So the first one, you can see the points is at the back, and then the smooth is on the front. So it's a little bit different. I'm not sure you can see here. It's not that clear, but with other plots, you can see it very clearly. So it's also good to check the documentation of ggplot to learn more about what these functions represent. So for example, here to remove the 95% confidence interval, look for SE in the documentation. It's in geom smooth. So if you go down, you can see SE, display confidence interval. See, it's set to true by default. there are other more detailed explanations, but over here, if you do not want the confidence interval, we can remove it, and now we do not have the confidence interval. Right, so I'm gonna copy this. All right, so we have talked about the adding multiple layers to the plot by creating different geometric shapes or points or objects. Now we want to talk about adding different properties. So we only have a basic plot. If you look at it, it's very vanilla, underwhelming, whatever you want to call it. It's very plain. This is in general for all Pokemon. But let's say if you want to look at how different Pokemons do on this relationship between attack and defense, you can add aesthetics to the point. So now we are adding aesthetics to the point itself rather than the entire plot. So the color now only applies to the point. And then when we run this, we can see the different types of Pokemons and how they do on how the relationship between attack and defense are. You can see the different colors here. So let's say if you want the points to change, you want to change the points from black color to something else, but you do want to look at different types of Pokemon, your color has to be outside the aesthetics. So over here, you can see it's inside the aesthetics. We are creating color for different types of Pokemon. But if you just want the color to change, you set the color to something else outside aesthetics. And then right now, it's gonna change the color from black to red. So I want you to try 3 minutes, set points to different colors of Pokemon type to your attack versus hit points. Let's spend 3 minutes. All right, let's continue. So what we have to do here is set ggplot, aesthetics, y, x to attack, y to hit points, add geom point, and set the color to type 1 in aesthetics, remember. And if you want, you can add geom smooth, which I will add here. And you can see we have different types of Pokemon, and they are for attack versus HP. So it's important where you set aesthetics, just a reminder, whether you set it in ggplot, so it applies to the entire plot, or whether you want to set to the point itself, it gives a different results. Okay, so for the first one, we are setting the color to the plot itself, the point itself. And for the second one, we are setting the color to the entire canvas. So what it's going to do is for geom smooth, it's also going to apply the color. So this is the first plot, which we set to only the points. And this is the second one, which is set to the entire graph. And then you can see for lines itself, for the lines it's smooth, the colors are also applicable here. So it depends on what you're looking at and what you want to tell your readers. So let's go on. Sometimes you want to change the size of the points for various reasons. First, it could be because it's too small to look at. Second, it could be because you want to emphasize the point itself. So we can use change the size using geom point inside geom point, and size equals an integer to change the point, the size. So right now you can see it's a little bit bigger than what we had before. So here, I want you to play around with the size of the group bar plot we created earlier. Add colors to type 1. Change the size of the bars. Instead of size, use width. Let's spend 3 minutes on this. All right. So I've just copied the chart we had earlier. It's with height. So now we want to add colors to type 1. So we have to add it inside Geom bar. So add aesthetics, put a comma first, so we know where we want to add it. So color equals type and score 1. Yes, and then change the size of the bars. Instead of size, use width. So it's the bars. So we don't want to set it outside, inside the aesthetics. We want to set it outside. So width equals, let's set it at 5. Let's see what it looks like. Okay, so right now you see it looks very strange here. It's because we have to use fill to fill the color bars. So remember, color is for the borders rather than the inner the color of the bars itself. So to do that, we need to use fill. So if you look at the first part, the first plot, we fill equals type, and then you can see the color is for the borders itself. You can see this is without the border, so fill equals type 1, and then outside we add color equals to black. So you can see the black borders here. So in Geom bar, when you use size, you are changing the size of the border. So we want to change the size of the border. So use size instead. So you can see the thickness of the bar change. The borders. So with width, we are changing the width of the bar itself. You can see now it looks strangely odd because we are setting it at a very large number rather than smaller number. Just to show an example here. Okay, so this is basically just some of the examples of setting different properties. Now we can also separate plots into different groups if you want to look at the properties of different groups. There are 2 ways to do this, which is to use facet wrap or facet grid. So we're defining subsets across 2 different grouping variables. For facet wrap, we are defining it against 1 variable instead of 2, or yes, 2. We can only use 2 variables here. So if you wrap it with only 1 dimension, so we use dot and squiggly line and then type 1. So we are looking at the relationship between HP and weight across different types of Pokemon. And if we have that with 2 dimensions, it's going to look it's going to be the same as the first one, just that it's going to look a little bit different. Just let it load for a moment. So this is for 1 dimension. So we can see for Dragon type, Fire type, every type Pokemon, we can see each different line, each different relationship. You can see which line is steeper, which one is more flat. And with this, we can look at, it doesn't look nice here, but if you print it out later, it's going to look better. We can look at status, legendary status for different types of Pokemon, whether they're mythical, legendary, sub-legendary, or normal type Pokemon for each category, each dragon, fire, psychic, water type of Pokemon. So we can do the same for facet grid as well. It looks slightly different. We have 2 dimensions now. So we have the X facet and the Y facet. So for rows, we have for each row represents different types. And then each row is a type, Pokemon type, and each column is a Pokemon type, and each row is a legendary status. So this gives you even more detailed plot of the graph if you're looking for that kind. So this can be used when you have more than 3 different variables or 4 variables you want to look at across the different types of variables. So I want you to try use facet wrap to facet or separate your attack versus HP plot by Pokemon status. So let's spend 3 minutes. All right, let's continue. So attack rep to separate attack versus HP. So let me just copy one of them. Attack. CK. HP. Separate your attack by Pokemon status. So we want to change to status. If you want to add color, it's fine. So we're gonna use facet red instead of facet green. Then when we set the plot, we plot it. You can see there are 4 different types of legendary status: mythical, normal, sub-legendary. You can see legendary Pokemon are mostly psychic or dragon type Pokemon. Makes sense. Mythical, probably psychic, and a little bit of normal and some fire type. And we have the most in normal type Pokemon. Oh, if you want to something that's interesting, attack and HP reverse for mythical and some legendary compared to legendary and normal. Just a fun fact here, which we plot we did. So last thing for today, yes, is to add labels or change the labels. So the X labels, Y labels, and title, we might want to change that. So we can do this by adding another layer. So it's, remember, ggplot is layering, layering, and layering. So we add a layer called labs, stands for labels. We can pass the X, the Y, the title, the color, and we can pass everything. So this is an example where I change the X, Y, title, and fill. So you can see this is the type _1. We want to change the label for the legend. The legend is, so for example, if there's a legend for fill, they want to change the label for that, we change that, we add fill. So for color, we change this to color. So now you can see the title is on the top, and the Pokemon type, the weight in kilograms, and then the type of Pokemon for Pokemon type. So another neat trick is to have your plot ready, so as an object, and then add further ggplot components to it. So like I said earlier, ggplot is a object-oriented programming language. So anything can be turned into an object, even plots. So when you set a ggplot basic plot, this is the basic plot into an object. So this thing becomes this thing. So, and then we can add extra layer to that as well. So it gives you the same results. So you can see it's the same result as what we have earlier. So I wanted to try for 3 minutes for your attack versus HP, small HP, small cap, set the plot as figure 2. Remember to add colors for Pokemon type, and then add labels and change the labels for X, Y, title, and color. So let's spend 3 minutes on this. Okay, so let's use our plot, our graphs. I'm just going to create plot attack versus HP. Add points. Jobs for point. Color equals to type 1. Colors for Pokemon type. Okay. And then we need to set to fig 2. So fig 2 equals, or if you want, you can use dash. Okay, and then fig 2 class labs X equals, let's just copy. So X is attack, Y is hit points, title space, attack versus hit points, plot, color, Pokemon type. So this is just an example. All right, so you can see our attack versus Pokemon type. Okay, so the last thing for today is to save your plot. Okay, so it's important to save your plot. We can use ggSave. It's a convenient function to save a plot. So first thing we want to do is to create a plot, set it as an object, like what we did with figure 2. So we can open up, look at a plot. You can see that weight of Pokemon type, age Pokemon type, and then we can save the plot here. So I don't think I have an image path set up. Let me see. Oh, yes, I do have an image set up. It's in handout image, yes. So you can save ggplot as different types. You can save as a TIFF, you can save as PDF, JPEG, PNG, so on and so forth. So we just set the plot to ggplot bar2. The path, which is image, you can set it to anywhere else you want. The file name, and so on. So I want you to try with 1 minute. So we're actually running out of time. So with 1 minute, I want you to set the save your graph for the attack versus HP. Okay, so what we want is, let's just copy, we have fig 2 already. So what we want to do is add some points. So I'm going to just call it fig 2 as the entire plot itself rather than separately. So we have fig 2, and we want to save as PDF, 3 different types. So let's copy fig 2. So this is the attack HP, PDF, and you want JPEG, JPG. Okay, so if someone's if you want to know, we can set a DPI. If you click on help, we can set DPI to different DPI. I forgot what the resolution. Yes, resolution. So once we are done, click run, and then the plot will be saved inside your plot image output. We can take a look at it later. So for the last part, we're going to practice what we learned today. Let's spend 8 minutes to create a plot of total points underscore versus catch rate. Add points to color, add points color to status. So add color to status, create a linear smooth line, use facade grid to examine this relationship among status, change the labels for title X, Y, and color. So I've provided you with some hints. Let's spend about the last 8 minutes to do this exercise. All right, so let's review what we did today. Let's go through the exercise first. So we want to create a plot of total point versus catch rate. So I'm going to copy this. So we're going to click ggplot. Oops, df ggplot. So I'm going to paste this in here first. Okay, so and then we want to add points to color, to status. So we want to add geom point, aesthetics, color equals status, create linear smooth line, which is geom_smooth, method equals linear model LM. So that's step 3. Use for site grid to examine this relationship among status. Next layer, facade grid. Okay, and then dot squiggly status. Change the labels for title, X, Y, and color. Last labs, X equals bullet points, Y equals catch rate, title equals my plot. I'm going to call it my plot since we are out of time to create a name for the plot. Color equals legendary status. So when we run it, we will have our graph. Okay, so if you do not want the what do we call it again? Yes, confidence interval, SC equals false. Which I do not want it to see. We do not want it to see here. So then we have our plot now. So we are going to knit this entire document to create a final output that we have for today. This serves as the completed workbook. So while this is loading, some major takeaways for today. We have made basic histograms, bar charts, scatter plots with ggplot. We have learned how to add aesthetics and facet for multivariate data. So for data with a lot of many variables. We have learned how to change the labels for our graph. And finally, the most important, after you make your graph or plot your graph, you have to save it. So we have learned how to save our graph. So at the most important of all, if you do not know or you are not sure about the code, or if you're not sure about the function or plot, make sure to look at the documentation and help. So we can use this template here to create multiple variations of ggplot. So aesthetics for mappings, functions, they have aesthetics, you have stats, you have position, so on. You have facet if you want, labels. And lastly, this is what we did today. An example. So when we have the plot here, you can see the entire output that we did. So this is a generated report of what we did. So the canvas, from the canvas to aesthetics to adding geometric objects, creating our first bar plot, all the way to creating more colors, setting facades, all the way to our final one, which is creating doing a practice. And finally, this is an example of where to look for what components of ggplot. So geom point, type, and everything. So just a sneak peek for tomorrow. Let's see. We will be going on to editing more of the themes, the colors, and setting custom colors. So going from this to something like this, and to our final plot, which we did today, which I show you earlier on the slide to create something like this. And extra more interesting plots like network analysis and creating maps and so on. So please come for the second part of the workshop. It will be more exciting than today. Okay, so that's it for today's workshop. If anyone have any questions, please email me or just let me know.